Our next speaker is Pyry Takala, CEO and founder of True AI, and he will discuss the hot topic for our school and for our hackathon: how to evaluate your dialogue model. Because what we are doing, we are trying to create models to evaluate dialogue agents. So let's welcome Pyry here.
Better?
Yeah.
Yep. Now I can even hear myself. Okay, great. So first of all, pleasure to be here and nice to see that so many of you here. As mentioned, my name is Pyry Takala. I'm from a company called True AI, and I will shortly tell you about that and also how to evaluate your dialogue model. But let me start with a small motivating example. So you've probably all been there. You're waiting for a train, and maybe the train doesn't come. And you maybe are in a busy situation. You need to catch the train pretty quickly. What do? You maybe reach out to the train company. You try to find out what's wrong. And if it's a modern train company, maybe they have a Twitter handle, or you can even message them on Messenger. And you see maybe they respond to you. So I tried to do this in the UK, where our company is based. And this is the kind of response that I got from there. They said that, OK, it may take up to 20 days before we respond to you. So I'm waiting for this train. It's maybe not so convenient to wait for those 20 days. So, of course, this would be a place where customer service could maybe work a little bit better. And customer service is, of course, one of the areas of dialogue models. And there are a lot of other areas as well. If you look, for instance, at education, for instance, 90% of the teachers in the UK have actually thought of quitting their job at some point because it's just so demanding. And actually, a lot of teaching work goes to preparation and then to conversing with parents, with kids, and so on. Or if you look at healthcare, for instance, there's around 400 million people in the world who lack even the basic healthcare services. They can't talk to a doctor because it's, of course, very expensive to talk to a highly qualified doctor. And maybe around 50% of the doctor's time is currently going to kind of desk work and so on. Again, another nice case for automating of dialogues. And one more interesting case, which is probably close to many of you as well. On an average day, the world is sending something like 100 billion emails, business-wise and personally. If you could automate some of these conversations, that would be, of course, amazing. And of course, it's not also so like kind of dark. The kind of vision that I want to see one day is that what would you feel like if customer service was always instantly available? If your personal trainer, for instance, cost you £1 or 1 ruble per month, or if Siri gave you kind of Oprah-level advice, assuming you appreciate that advice. That's kind of the vision what you really want to see as a dialogue researcher. It's not easy to get there, of course. So what am I going to talk today about? First of all, I'm going to tell you briefly about our company, True AI, just so that you can put into context what I'm talking about. After this, I will cover basics of dialogue models. Some of you are probably very familiar with it, so if it gets if I'm talking about things that you already know, I can go a little bit faster, let me know. So I'm going to talk a little bit about evolution of dialogue models. Where did we start? Where are we now? What are basic models such as RNN, sequence to sequence, and what other models are there? And what are kind of characteristics of dialogue models if implementing them with deep learning? And then I'm going to talk a lot about model evaluation. So things like why do we want to evaluate and what do we want to evaluate exactly? There are different use cases. Then I'll cover human evaluation, which is perhaps the kind of fundamental way to evaluate. Then some automatic ways of evaluating dialogue models. And finally, I'll give you some example also from work that we are doing. And then at the end, I'll also discuss quickly some challenges of dialogue modeling and dialogue model evaluation. Starting with what our company looks like. So True AI is a London-based company. We are a team of deep learning researchers, and we are aiming to help the customer service operators by building good dialogue models for them. We are not really building chatbots, which many of you maybe have seen. We are rather doing something like this. So here's a sample conversation. Hi there, can you help me? Hi there, yes, of course. What seems to be the problem? My Wi-Fi is super slow. What should I do? This may be a typical conversation for a broadband operator. Usually, the customer service operator will just start typing there a response. But in our case, we're actually providing suggestions to the operator that they can start sending. It means that you can click or use a keyboard shortcut to select one of these and send it straight away, which can be much faster, both because you don't have to type, but also because the suggestions often contain some information that you may not otherwise find. And of course, how you get these suggestions is purely from a deep learning algorithm that has learned from historical conversations. I think my Wi-Fi is also working, so I will also quickly demonstrate how this looks like in practice. So we have integrated, oh, you can't see anything. So we have integrated to this system called Intercom. And I can say here, so this would be the view of the customer. I can actually pull the view of the operator to the side, so you can see both at the same time. So I can say here, hi. And now this is the operator view, the customer service operator view, and you can see that this is appearing here as hi. And what I need to still do is to log into our service. Oh, I have logged in. OK, then I just need to refresh the page. And I may have found a bug because it's not showing anything. Let's try logging in again. All right, let me hope that our other live demos will go a little bit better. What you would typically see are some suggestions how you can respond to this. Maybe I'll try at the end of the presentation if there has been a glitch and I can make it work again. Regardless, what you would start getting is that the system sends the hi to our server, and the server starts giving you suggestions how you could respond in this case. So much about our company. What I want to next discuss is how did kind of dialogue models emerge? What did we start with, and where are we now? And I'm going to do this with some example conversations. So maybe the most simple kind of dialogue that you can think of would be something where a person says hi, and then the target response would be something like hello. Of course, programming this is really trivial. It's just a question and an answer. That's it. And people have developed languages even to do this and some more complex systems. So for instance, AI/ML is one of the popular languages that you find. I think it was developed probably in the 90s or so. It's quite an old language. You just have some kind of pattern, and then you have some kind of template which it sends. And that's very simple to build. Of course, with this trivial example, you could just use some kind of if-else statements. Then maybe your dialogue is slightly more challenging. So maybe you have something like hi, and the response is something like hello, Pyry. And maybe kind of programming if-else statements for this, for let's say everyone in this room, would start getting a little bit tricky because you would have to have actually one for every single person's name. So what you then do is you have some kind of question, and then you map that to some kind of expression. What do I mean with an expression? This again, AI/ML. What you have here is that you have some kind of pattern that I am star. So star can be some kind of variable. And if this happens, then the template is actually saying that, OK, let's reply with hello, and let's say that let's set the name to something like a username variable. And then if I later on talk to this person and they say good night, I can then say that hi and then the person's name. So this is kind of a question to expression. Again, fairly simple to build, and AI/ML or something like this could be used for that. If you are building something very trivial, if you are building, let's say, a system that you need to talk to your thermometer or check your kind of account of your bank, this is probably a very, very fine system for that. But if you get a little bit more complex, it starts to break down a little bit. So why might that break down a bit then? Maybe, for instance, your dialogue goes to something like this, where you say, let's say, hi, and your target response, if it's a day, it might be hello, Pyry, or if it's an evening, it would be evening, Pyry. So essentially, you kind of get into a situation where you have some kind of question, and then you have some kind of an expression tree. So you have, depending on where you are in the tree, you might have different answers to the same question. And this is also possible, probably even to build in AI/ML. And then companies like IBM have kind of developed also this kind of systems where you can say that, OK, if I'm in this condition, and then I go to these conditions, then that's what I should respond. And that also kind of works if the tree is fairly constrained, if it's fairly small. I was actually also thinking that I'd show you a quick view to IBM's demo. So if you kind of check what is, for instance, online on IBM's site, just to give you a flavor of what can you do with this kind of systems. So I think this is basically their system where you can do something like drive a car. And you can say to it, let's say, hi, can you see that all right? Hello, I'm doing good. I'm there to help you. Just say the word. And then I say maybe lights on, and I think that will turn the car's light on. You can see that there. Then I can maybe say to this car that, hey, stop car, for instance. And it says that I want you to turn to something, which is not really what I wanted. Or I can maybe say that, OK, play some music. And it doesn't have any soundtrack information. But then if I tell it play radio, it says that, OK, I actually have a radio. So it's, if you try to kind of map everything with rules, it starts to get quite tricky. It maybe detects some of these things, but then it doesn't detect other very obvious things, like, let's say, playing music or playing radio would be very similar in this context. But that's, anyway, what you can do with IBM systems today. And if you have a fairly simple use case, maybe with talking with a car, you can fairly well make kind of most of the important functions of the car work. Then what you maybe want to also consider is to do some kind of machine learning on this system. So maybe someone could say that, hi, Pyry, or hello, Boris, or ciao, Anna, for instance. And maybe you then want to respond in a way that, OK, if it's the day, let's say hello, person's name. And if it's the evening, let's say evening, the person's name. And essentially where you end up now is that you have a question, and then you have a machine learning module, and then you have some kind of expression tree. And again, you can use something like IBM to build this. So here's some kind of training or examples of what you consider as certain intent in this case. So you say that tell me about the current weather, or it's raining, and all of these mean that someone is interested in the weather conditions. So you can kind of combine all of this. And as you can probably tell, this system is starting to become fairly complex. Maybe you had kind of that system, but maybe you want to even add some more machine learning systems. So maybe you want to, for instance, have something also that detects entities. For instance, it detects weekdays and so on. And you really start ending up in a situation where you have, for one question, you have many machine learning modules. You have kind of an expression tree. And probably the biggest problem is that you have to also maintain it all the time. So if anything changes, your whole tree might change quite dramatically. And from all of this, for kind of complex language conversations, these kind of chatbot systems typically fail, actually. So if you have something fairly simple, if you want to, let's say, operate your garage door or whatever, that's something where you can definitely use a system like this. But if you want to carry out the natural flowing conversation, I would say these systems will not really work for that. And that, of course, leads us to kind of machine learning and especially deep learning. So when you have kind of rule-based systems, you had something like a conversation, which I'm going to call context from now on. and then you had something like a response R, to how to respond to that. So in a rule-based system, you say kind of, okay, this C maps to this R. And yeah, it's easy to make work, but it may miss kind of many subtle nuances, and it doesn't work if it gets complex. In machine learning, you kind of try to learn what is the probability of R given a C context, and you kind of try to find approximately what is the R that maximizes the probability. And this is, of course, very nice for generalizing to new input. One of the challenges is that you do require some data. So if you are doing this for yourself, and unless you have recorded your conversations for quite a while, it's going to be quite difficult to do this. Also, sometimes you don't exactly know how this is going to respond. And depending on the application, this might be an issue or not. And sometimes it also requires a bit of math understanding unless you are using some kind of API. And this talk will focus mostly on deep learning methods. Many of these is applicable to, there are some other machine learning methods also to kind of do dialogues, but I'm going to talk mostly about deep learning. Yeah, so much about evolution. So now we have come from kind of question-answer models to deep learning models. And some of the basic models are recurrent neural networks, sequence to sequence, and then there are some more advanced methods. Before I jump into the theory of each of these, I'm just curious how well you know this. Who's fairly familiar with recurrent neural networks? Can you just raise your hand so that I get a good understanding? About maybe a bit more than half, okay? Or two hands. And sequence to sequence would be familiar to how many? Okay. All right. I think I'm going to do this fairly quickly. If you are not familiar with this, there's a lot of good tutorials online. You'll pick it up quickly. The ones who are familiar with me, with this, bear with me. So a recurrent neural network is something where you feed your inputs, one input at a time. You have some kind of a hidden layer or multiple hidden layers, and then you produce some kind of output. And the nice part is that the input that you are feeding, or the transition from one time step to the next is always computed in a similar way. Another way to denote this is this. So you have some kind of input x here. It's coming to this hidden state neuron, which is applying a w to it, and then it's computing some kind of output from it. So that can just be unfolded like this. And as you can see, the parameters v's are repeating here. So it's fairly efficient compared to having, for instance, a different set of parameters each time step. And you can have, of course, different things happening inside of the neuron or the cells that you have inside there. So in this case, for instance, in the forward path, it might be a tanh. So you multiply the state with some kind of W matrix. You add some kind of bias, and essentially you combine these two, and you get both this and that out of there. And what you then typically compute is you compute some kind of a loss function. So essentially, if your target class is, let's say, class 3, and you have this much probability mass, of course, your probability mass for your target should be 100%. You should, if your model is perfect. And as you can see, if your P for the target is always perfect, then your loss will be 0. You have found a perfect model. And then you start using this loss to train your model using backpropagation, which is, if you're not familiar with backpropagation, this is not a tutorial on that. So unfortunately, you'll have to study that somewhere else. All right. So what's nice about recurrent neural networks? RNNs can be actually used to generate already text. So one very simple example, how do you convert text into numbers? You convert, let's say, A into a vector which has 1, 0, 0, B to 0, 1, 0, and C to 0, 0, 1. And then you convert a lot of text in some kind of encoding like this to vectors. You train your neural network with all of that text, and then you can start generating. And I'm going to show you just a very quick demo on how that looks like. So for instance, here you can say that, okay, my name is, and then you can say that, okay, I want a 10-character name, and I submit something. And this is, for instance, suggesting that it's based on. Or I can say, okay, today is, and maybe, let's say, 10 characters again, and it's saying today is powerful. So it's kind of picking up that there's some kind of language pattern. So these are not completely random characters, but it doesn't really make sense. Mostly the reason being that it's trained on a character-by-character level, and kind of keeping the meaning of the sentence is fairly difficult. But you can kind of generate that. There are also some other online demos. For instance, Andrew Karpathy has a lot of online demos. If you haven't come across them, please do check them out. Here's a lot of training data that it trains on. Here you can see kind of the loss decreasing. And here you can see some kind of predictions that it's making. So you can see that it's repeating a lot of the same words and so on. It's not very clever, but it does look like English at least. So it's not absolutely completely random. All right. So this is what happens if you start feeding kind of character by character to a standard RNN, some information. What you typically actually feed in is some kind of word embeddings. Probably most of you do know word embeddings, but word embedding is just a word represented as a vector where many of the dimensions can have values, so it's not a one-hot vector. And typically the same words have kind of similar meanings in that vector space. So that's how you then can feed so for instance, for this model you can feed then here a word embedding always, as opposed to a single character. And one of the most commonly used, fairly standard ways to generate dialogues now is something called sequence-to-sequence. So it's basically a model that can be used to map any kind of sequence to any kind of sequence. It was initially used more in machine translation, and you have basically an RNN that kind of encodes the information, and then you have something that decodes it also. And you typically use something like LSTMs as the RNNs, as the cells of the RNN. So this is how it looks like. You maybe feed here, how are you? And then into your model, and then your RNN is then outputting fine, thanks. And just to get the terminology right, the first part here is called an encoder, and the last part is called a decoder. So that's kind of the basic way of for instance, generating dialogues as well. And of course, you could initially people used this just to translate. So you had here kind of the thing that you wanted to translate, and there what you outputted. But apparently, it works fairly nicely also for at least simple dialogues. And then there's a lot of new developments in dialogue research. Just a couple of examples. So sequence-to-sequence is there. You have something called memory networks, and I saw that I think Jason Weston is going to talk with you, so he's going to probably tell you much more about that.
It's the next lecture.
Perfect. OK, so you'll get very familiar with this after my talk. Then you have something like hierarchical models. So hierarchical models is something where you, for instance, consider each sentence, and you find some kind of sentence embedding. And if you want to, let's say you want to respond to something very long, then you can kind of have maybe even a paragraph vector and so on. And then you encode it in a hierarchical way as opposed to everything just sequentially. And then people have also experimented with attention. Attention is one way to kind of to kind of, let's say, from here to access one of these earlier words in a more efficient way. And some people have actually even developed models that kind of skip the whole RNN concept almost and are doing everything just with attention. All right, so that would be the basic introduction to all to kind of standard dialogue models used in deep learning. There are many different models that people are experimenting with, but these are some that you probably should be familiar with at least. I'm going to jump next to characteristics of deep learning dialogue models in general. So we wanted to kind of find this response that has the highest probability given a certain context. So the machine learning approach is to use some data and then approximately find that. And there's basically two ways to do that. You have generative models and you have retrieval-based models. Generative models look something like this. Here's, again, the encoder that you saw. And then you start generating. You generate one word, fine. And then you generate another word, thanks. And at some point, you stop. That's how a generative model essentially works. You just start generating, for instance, word by word or even character by character. Retrieval-based model is slightly different. So a retrieval-based model would have, let's say, two different encoders here. How are you? And you are welcome, for instance. And then it would check, OK, what's the compatibility between this vector and this vector somehow, for instance. And then you get, let's say, a score 0.9. And then you feed it another option, what you could respond. So you could say that, OK, I'm fine, thanks. That's another alternative how you could respond. And then you feed it maybe a lot of options that you have. So you know sentences that could be like a valid response in a dialogue. And then you pick the best one, essentially. So it doesn't generate any new sentences. The sentences are already in your corpus. It just essentially scores them. Just to contrast these two approaches, so the kind of generative model is nice in the sense that it can generate really unique sentences in your dialogue. The challenge is that if you want to grammatically correct and if you want to make sure that it's always sensical, that's not guaranteed at all. Retrieval-based models do kind of make sure that the grammar is correct and so on because it's already written by a human. The challenge there is it can't really suggest anything that is outside of your training set. Then you have something like closed domain versus open domain. So let's say, what is my bank account balance would be something very fairly closed domain. So you can restrict your conversations to be just about one specific topic. For instance, our dialogue systems are restricted just to customer service and typically to customer service of the company that we are serving. That's much easier, of course, to get to work. You can also go open domain, which means that you just try to kind of answer absolutely anything. And if you have some kind of entertainment bot, for instance, that might be something where you might consider being just completely open domain. Then another division of dialogue models, you can have goal-oriented bots. So let's say you have doctor-patient conversation. There's usually a fairly clear goal of that. The doctor wants to maybe find the symptoms or find what's wrong with the patient and recommend some kind of cure for them. Or in customer service, you maybe want to, and you can actually have many goals. Maybe in customer service, you want to help the customer, but maybe also want to sell them something more, for instance. And some examples could be, for instance, Ubuntu dialogue corpus would be a good example of data that is fairly goal-oriented. So you try to solve Ubuntu problems. Alternatively, you can have also some non-goal-oriented systems. So if you want to kind of just entertain someone, or maybe you want to just hack together quickly a chatbot for fun, that could be a non-goal-oriented bot as well. And maybe some kind of Twitter dialogue corpus could be quite a nice one for that as a data set. Talking of datasets, datasets are actually often a bottleneck in dialogue research. So there's one nice paper by Julian Serban and a couple of others, the link of which you can see there, and it lists many tens of available corpora. But if you look at these, for instance, the total number of dialogues in this one, they are actually very small. Typically for our company, if you want to train something, we are saying that you have to have at least 50,000 conversations. So for instance, they have many pages, so they do have some corpora that we can use, but many of them are just too small, for instance. Some of these might be also spoken language and so on. But typical datasets that people do use, movies, Twitter, a Barbie dataset, which I'm going to tell you briefly about, and some narrow domain datasets are quite commonly used. And then you have some kind of standard datasets, and the nice part about standard small datasets is that they are very good for sanity checking your model. So if you decide to implement your own RNN or sequence-to-sequence, for instance, and you're not quite sure if it's working correctly, there are some datasets, probably the most famous one being Bobby, which you can use to just test, do I get the same performance as everyone else? So they have developed something where you have like, Daniel picked up football, dropped the football, got the milk, took the apple, how many objects is Daniel holding? And the answer is 2. And they have a lot of these kind of questions where you have maybe just 4 or 6 words or so in every utterance in the dialogue. And it's then very easy to check, do I get the same performance as they do? And I think Weston is going to tell you more about this as well. The nice part about this is that you can kind of check for each of their tests, do I pass it, do I fail it, and so on. All right, that was a very brief introduction to dialogue models. I'm going to next jump to actually how do you evaluate these systems. But before that, are there any questions in the audience that I should address? Anything that was left very unclear at this point? All right, I'll take that as a no. So let's start why and what do we really want to evaluate. So the question is really why do we want to evaluate? And it may seem quite trivial, but there are actually several use cases. So one of the reasons why I want to evaluate the model is I just want to know how good it is. So again, coming from a business case, I want to know, can I actually sell this product? Or if I was developing a medical bot, maybe I want to know, does it give valid medical advice? Or is it something that will start killing my patients? Alternatively, maybe I don't want to kind of objectively know how good my model is always. Maybe I just want to know which model is better, for instance. So I have model A and I have model B. And I want to know, OK, does model A perform much better than B? And which should I develop further? Where should I optimize more hyperparameters, and so on? And finally, I may want to also know what are the model's strengths and weaknesses. And why would I want to know that? First of all, maybe I'm showing this model to someone else, and I want to explain why does it work, what should you ask it, and so on. But perhaps more importantly, if I'm a researcher, I want to also know where should I develop this model next? What should I where should I focus my efforts in? So if the model is, let's say, very good with certain kind of short messages, but it's very bad with very long messages, then I know that I need to do something about long-term dependencies, for instance. And of course, the most basic way to start evaluating then dialogue models is human evaluation. So you of course can come up with some automatic ways to evaluate, but essentially it's typically a human that you want to converse with. And you basically kind of generate some kind of response for different contexts, and then you give them to a human and start asking how good is this, and so on. And you kind of ask, what does the human think of the model performance? And of course, the nice part is that it's very close to the real-world situation. And ideally, if I had the choice, I would evaluate all my models just with a human. The disadvantage is obvious that it takes a lot of time. Maybe during this week, you may want to try evaluating your own model, and you'll very soon notice that just evaluating 100 conversations, if it gets any more complex, it actually takes a lot of mental energy to do that. And then you have a lot of areas that you want to think about. For instance, you want to think, what's a good answer? You want to think about, should I just evaluate everything once, or should I evaluate everything twice? Any idea why you would want to evaluate everything twice? So, Errors? Yes. Yep. So yeah, I think typically what I at least notice when I start evaluating is that first of all I might make some errors. Also, maybe in the beginning I was a little bit less, let's say, more strict or less strict, and I want to kind of, let's say, for instance, make them comparable, all the scores that I'm giving. Or other things that you maybe want to think about is, should I ask something else from the humans, or should I kind of have some kind of should my annotators have some kind of background knowledge and so on? I'm going to deep dive actually into this, into a couple of this. So here's an example of how you could give scores to your model. This is from, I think, one Google paper. So they define a scale from 1 to 5. And you say that, OK, 1 is really bad. Completely off-topic statement or question, nonsensical, grammatically broken, doesn't provide an answer. Then you have something mediocre, acceptable, it's on topic with flaws, made it seem like it didn't come from a human, but it implies an answer. Then they have you good, and you have something that's excellent. Any issues with this? Would this be a great way to evaluate your model? What do you think? Do you think this would be valid? Maybe?
More or less.
Yeah. Yeah, so I think this could be definitely valid, and Google used it in one of their papers. So actually we started using this as well. And then we evaluated our model, and we also then brought this to our customer, and then we to automate their customer service and ask them to also use this to just give us some feedback how they like it. And this is actually what they said. They said that they don't like this. We just want to know if we can use the suggestions or not. So it's actually, for instance, far too complex. Their comment was that I don't know what's the difference between excellent and good, and if my answers are acceptable, can I show that to my customers or not? So for an academic purpose, I think this is actually a fairly good way to evaluate your model, but then depending on the use case, it may or may not be that good. And then the question really comes down to, OK, what is a good answer? So let's say I'm saying that, OK, my internet is down. What's a good answer for that? Any examples? What would be a good answer for this?
So you should ask more details about this.
Mm-hmm. Yep. Yep. Asking more details would be definitely valid. Any other options that you could do? Huh? What is your name? Yeah. that would be probably a valid thing. I listed a couple of examples that you actually see also in data. So you maybe see that, OK, have you tried rebooting the router, asking a question? And actually, this is a nice question in the sense that it's also asking you to do something that might already resolve the problem. Sometimes companies say that, OK, please call us at certain numbers, and we can investigate. Is that a good answer? Well, kind of. But then if at the phone there's let's say another dialogue system that says that, hey, go to our website and check out our chat, it becomes an infinite loop. So it depends. Then maybe this is actually what we were initially producing. Have you checked for area fault set __ to URL __? It's kind of OK. If a human edits it a little bit, you can actually send it away. But as such, it doesn't really provide the customer anything. It's also grammatically correct and so on. Then, for instance, this might be then a better option, of course. Or let's say you can say that, OK, we have an area fault. It will be fixed in 2 hours. That's probably the best case if you can already locate the customer and so on. Of course, maybe that's not always possible. So it really depends what is a good answer. And when you are annotating your model, you actually have to think quite hard what is a good answer for this use case. Initially we started, for instance, saying that the middle one is actually a good response, and because it meant that our model is learning really nicely. But then, so it's a good response from the point of view of the person who's building the model, but it's not a good response from the point of view of the customer. So you have to also consider the viewpoint there. Then you maybe also want to consider what is the scale. Is it from 1 to 3? And what is wrong with the answer? So a couple of examples. You saw the scoring from, let's say, bad suggestion to the point suggestion. Actually, our customer that was not happy with this scheme came up with the scheme that, OK, 1 is bad, 2 is you can send it, but you have to edit it a little bit, and 3 is it's great. And they also wanted to do exactly the same for language. So they actually wanted to split it into 2. Is the language good, and is the content good? So if it was grammatically broken, then it would get a low score, and in the other dimension. Then sometimes you maybe also want to ask for comments from maybe yourself or from whoever is annotating your data. So maybe they want to say that, OK, this address is the question, but the information is outdated, which might sometimes happen if you have a lot of training data and some of it is not maybe valid anymore, for instance. And that maybe also helps you then think, okay, how do I then develop my model further? Then maybe you also want to classify the errors. So maybe you actually want to say that, okay, here are the 10 classes of my of errors that can happen, and maybe one of the classes is other, so that you have like a fallback option. But let's say one of them was outdated information, for instance, and let's say another one would be that the wrong customer name, or and so on. And then you can come up with different classes that hopefully help you understand what's wrong with your model and maybe also how to develop it forward. And then maybe you also want to kind of classify or comment on the context. So maybe you could say that, okay, I was asking why is my internet broken, but the person didn't provide let's say their address, or their name. So it was very difficult actually to give any really good response, or at least any response that helps the customer directly. And you could also kind of not only score the responses, but also the context. Then, so that's kind of how you could annotate. I'm gonna now talk about how do you actually do the annotation. And it may seem trivial, but it's actually not as trivial as you'd sometimes hope. So of course the most trivial way to do it is that you take a bunch of context and responses and you start scoring them. But what you also want to consider is that maybe you want to have actually multiple annotators, and maybe they don't always agree. So maybe I say this is a really good suggestion, and you say that it's a mediocre suggestion. What do you do then? Do you take the average? Do you discard that, and so on? Also, is the annotator kind of competent is sometimes a very valid question. If I'm doing a bot that is coming up with, let's say, recommendations again for medical or legal issues, I probably couldn't even act as an annotator, at least not for many of the sentences. I could maybe say that it's grammatically correct, but if it's actually correct according to the law, I maybe wouldn't know. And of course, you have to also consider the cost. And what you often want to, for instance, measure with annotators is that you measure, for instance, their disagreement, and you kind of correlate them and check, okay, do the annotators at least roughly agree? Maybe they sometimes are a little bit in disagreement. But then also what you can do to kind of overcome many of these issues is that you can annotate some examples first yourself, and then you can share this with the annotators. So you can kind of provide some kind of examples of how should you annotate, how should you not annotate, and so on. You can also, and you should also, if you are not annotating yourself, and maybe even then, you should write some kind of instructions. What are the principles? How do I annotate? What is a good suggestion? Is it something that just carries the conversation forward? Should it go towards the goal if you are doing a goal-oriented thing, and so on? And then it's quite good to monitor annotator performance. So I was actually many years ago, I was doing a project about sentiment analysis where we outsourced some annotations to Philippines. And what we found quickly is that we can't let anyone annotate like thousands of sentences straight away. We started giving them like first just 100 sentences, and then we checked is the quality roughly okay, and then we started giving a bit more. And then when we were really happy with that the criteria was always the same, then we would give the big bulk of the annotations. And that's, of course, sometimes it's also tricky. So if you're using something like Mechanical Turk, which is this Amazon service where you have annotators for very low prices, then maybe you can't even always control who's your annotator. So this can be an issue sometimes. Yeah, then you maybe want to compare annotators to each other. And sometimes the annotators maybe should also talk with each other just to say that, OK, why did you give me a 3 and I gave it a 5? And then you maybe realize that, hey, there's some criteria that we are not thinking of or are thinking of differently. Yeah, of course, you want to give some feedback. Sometimes your annotators are actually the people closest to the data, and maybe they are coming up with really good ideas on how to develop your model, or at least noticing that, hey, your model is always in these situations really bad. And that's actually what we notice sometimes in our company, that sometimes a person building the model is so close to the model that they don't see something very obvious that an annotator says right away, and it's actually very trivial to fix even with a rule that, let's say, cleans the data. And how do you actually do annotations? So I think the first thing is you should do it yourself. But then if you need, let's say, 1,000+ annotations to check how good is your model, you can use your friends. There's kind of cheap labor on many online platforms. Mechanical Turk and so on work as well. What we are currently actually thinking of in the company to do is also to save some of the annotations. So if our next model makes the same prediction, we would actually retrieve that annotation from the database. So if you do annotations on the same data many times, then you actually may want to also cache those annotations. That's everything about human evaluation. I'm going to jump next to automatic metrics. So talking of automatic metrics, I think you probably already got the point. Human evaluation is very good, but it's very expensive. And that's why you really want to do some kind of automatic evaluations as well. And what people have started doing is that they take some kind of automatic metric. Here's some examples. And they have checked how well does it correlate with the human scores. So if the correlation is non-zero, it's quite good. So you can see that human-to-human correlation is here something like 80%. So humans don't always agree, obviously, but at least the correlation between two humans is very good. And then for metrics like Blue or Meteor, it's in the ballpark of 0.3. Some embedding average similar, and so on. Skip plots would be nice, but it's statistically not so significant. So here's some examples that you can use to automatically evaluate, and I'm going to now dive into this. So what you really want from a system, from an automatic evaluation system, is that it has a high correlation to the human evaluations. Otherwise, it's not going to help you, obviously. Here's one way to classify these automatic metrics. So you have kind of metrics that just check, okay, does my model approximate the distribution correctly? Cross entropy or log loss, perplexity, and recall would be such. Or then you have things like Blue, Meteor, and performance of some maybe previously trained models, which would be closer to kind of, is this model good? And I guess human evaluation would also fall more under the latter. I'm going to jump quickly to cross entropy, so or log loss. So you remember maybe this picture from the beginning of the talk. You had some kind of class here, and if you have a lot of probability for the correct class, your log loss tends to 0. So that's just this. And the advantage of log loss is, of course, that when you are training your model, you are already counting it for free. So why not use it? And you can see your loss going down nicely, and you have at least some idea that the model is learning something. The challenge is that you may have a model that gets the lowest loss, but if the humans evaluate it, it may actually not be the best model. If the loss is not going down, you know that your model is not learning, so it does help you a lot. And usually if you have a lower loss, your model is probably better, but it definitely does not guarantee that. A very related metric is called perplexity, and it's essentially just exponential of the log loss. And this is reported in many papers that you'll see, and it's kind of describing just how confused the model is. And it has very similar advantages and disadvantages. It's very simple to compute. And it's also, but it's not always correlating with human evaluations. Then one metric that I like a lot is called recall at x at y. So it's essentially saying that, okay, for each context in the data, let's calculate kind of this probability for real response R, and let's have some kind of fake responses that we are maybe choosing randomly, and let's see how high does the score of the real response rank as opposed to fake responses. And what should happen is that if you have the correct response or fake response, your model should always score, of course, the correct response to the top and the fake response below it. So if your model is really good at distinguishing good and bad responses, you can get a very high recall value. Of course, the trouble of this is that if you have a generative model, you can't actually use this, so this is for retrieval-based models only. Just to make this a bit more concrete, here's a quick example. So let's say you have a retrieval-based model, and it gave us 3 different contexts, 1, 2, and 3. And then you have responses A, B, C, D, E here, and it gives these scores. And here's the label, so 1 means that it's the true response. And here the true response is the first one, and in the middle one it's called, it's the middle one. Oh, sorry, on the right-hand side, it's the middle one. So then the question is, what is your recall at, let's say, 1, 3, and 5? Starting with recall at 1, what would you say is the recall at 1 based on just these 3 data samples? Just to check if you got how you compute this. So we are saying, so just to recap, so we are saying that, okay, in how many cases of these 3, and you would have in reality probably hundreds, is the model ranking the correct response as the highest one? So if I'm counting recall at 1, it means that you have to have as the topmost response, the correct response always there. So, yeah, exactly. So you have only here you have the correct response on the top, and here it's not on the top. So the recall at 1 would be now 33%, so in 1/3 of the cases. Now if I go to recall at 3, can someone tell me what would be the recall at 3 for this? Yep. Yep, exactly. And recall at 5? Yes, exactly. So in this case, recall at 5 wouldn't even tell me anything because it just looks like the model is doing perfectly. Yeah, and you could of course compute also recall at 2 and recall at 4, but they don't change in this example. In reality, of course, you would do much more context so that it's statistically a bit more stable. All right, then other ways. So these were all ways kind of how to look at do you actually model the data distribution correctly. Then maybe you want to also think, okay, can I compare this to some good options? So let's say my context is how are you? And I had some annotators who said that, okay, the good response for this would be good thanks, I'm fine thanks, or not too bad thanks. And this is something that happens very often in machine translation and summarization. So it kind of sounds like a sensible approach to think that, okay, if my annotators are giving me something like this, or if my correct translations are something like this, does my model generate something similar? And if it does, it's probably a good model. So in machine translation, this is quite a commonly used technique, and you could also apply the same for dialogues. So the metric that I'm talking about is called BLUE score. Don't ask me where the BLUE comes from, but you can Google it. They have a nice Wikipedia article. And what you really start checking, okay, if I had these kind of words together, do the same words occur also in my proposed suggestion? And here's it's somewhat more formally. So you essentially count kind of counts of words in your kind of reference point and in what you are actually suggesting to be the case. And you typically use some kind of n-grams. So you combine many words. So you don't just check is this word and this word there, because that often doesn't give you very robust kind of metric. So coming back to this picture, if you just looked at one word always, that might still be very different meaning, and they might be in different places, so the sentence might be very different. So you look at kind of combinations of words. and also you do have to sometimes think, okay, should I penalize my model kind of for very short or long responses and so on. And this, as you saw maybe in the table in the beginning, this correlates sometimes a little bit better than, for instance, log loss might correlate. But it's definitely not pure substitute for human. And blue has also some issues. So for instance, if you want to have some synonyms in your dialog responses, so maybe your, actually let me make an example. So maybe your maybe you were saying that, okay, good thanks is a good response, but maybe then someone said that great thanks. And blue would actually not then consider that as a correct thing to say. But then something like Meteor, for instance, would say that, okay, it's a synonym, great and good are synonyms, it's fine. So these kind of extensions might be then fine. Rouge is also, I don't know if you call it an extension or an alternative, but it's a very similar metric. And maybe I'll just go quickly back to show you how these methods perform, because I'm not sure if you remember it anymore. So Meteor, Rouge, and Blue 4 seem to all correlate in a fairly similar way. So which one you really want to use, it's probably up to you. And maybe you even want to check which one correlates with your data set best with human if you have a lot of time. But I would probably just pick one that you can easily find an implementation of, or that you can easily implement yourself and go with it. All right. So that would be kind of the quick overview of automatic evaluation, ways to evaluate. One way that I haven't maybe talked so much about is are all kinds of word embedding averages and so on. Essentially, if you have had some kind of model that you know that performs fairly well on the data set, you can always at least compare what kind of scores would it give to this, to my suggestions, how would it rank them and so on. So you can also use kind of existing models to help you understand how well your model is doing. But just to give you an evaluation example, and this is actually related more to human evaluation. So if you have trained 2 models and you have evaluated them, how do you know which one is the best? So that was one of the use cases in the beginning. You want to know which model is good. So maybe you have kind of 3 possible extensions, and you have 100 data points from human evaluations, each on the scale from 1 to 5. So you had essentially, how much is that? Maybe you had 400 annotations made by humans. So 1 model and then 3 extensions. And maybe this is then what your annotations look like. So you average all the annotation scores, and your base model scored 3.9, extension 4, extension B 4.1, and extension C 4. So what's a good model? Well, all of them seem to be actually better based on this than your initial model. But if you have read more statistics than some very basics, you'll probably know that you maybe want to look at something else as well. So maybe you want to look at something like standard deviation and standard error of the mean, which means that, okay, you just took 100 data points. This might be 4, but there's also a chance that you just got lucky and maybe it's actually 3.8 and so on. And then you conclude that, okay, maybe I want to do some more human evaluation. You can also do some things like sign tests. And in this case, a lower value is better. It's showing that, okay, with the sign test, the extension B seems to be statistically better than the base model. And then if you really want to go hardcore statistics, you can do things like Wilcoxon signed rank test, and you really conclude now that your extension B is better, at least based on these numbers. Usually, you are probably good even with these ones. That would be a kind of quick overview of model evaluation. I'm going to jump next to kind of challenges, and also, those are challenges in dialogue models in general. Any questions on evaluation? Any metrics that I maybe didn't cover that you are curious about? Any, or everything clear? Come again?
How they compare comparison between skip thoughts. How to use skip thought to evaluate?
Very good question. I'm not actually quite sure what they're doing. The challenge with this skip thought one in this picture is that if you look at the p-values of the skip thought, at least here it's not very significant. Here it actually does seem quite good.
So how it is used for evaluation?
That's a very good question, actually. I'm not entirely sure. It's not something that you'd standardly use for evaluation. It's one deep learning model that they have used. I'm going to have to give you the paper, actually, to tell you how this is used in this particular case. Sorry, I don't have an answer exactly for that. Any other ones? All right, I'll move to challenge system. So as you maybe noticed already in the beginning, people have done dialogue modeling for a long time, and it's a tricky problem. That's why all the chatbots are not working that well. And there's a couple of different things. So for instance, language has a lot of nuances. So maybe I'm saying that, oh, I cracked that math problem, and someone is saying, you're a genius. Or someone says that, oh, I figured out what that emoji means, and someone is saying, you're a genius. Maybe the meaning is a little bit different. And the nice part is that deep learning handles these kind of situations much better than previous kind of traditional NLP systems. It's still not capturing maybe all intricacies of language, but it does capture it much better. Another challenge would be open domain queries. So maybe you want to ask your algorithm, oh, what do you think of the plot of that TV series? And this is something that is really difficult. Practically any system that you see in production today is kind of is working in some kind of narrow domain. So I would definitely not try to start with an open domain system unless you want it just to be a really kind of a chit-chat bot. If you go to kind of the best systems like IBM, or maybe you take Siri or something, you can ask a certain number of questions, but asking anything is really difficult because you need to then training data on anything. You basically need a model that has lived in this world, which is something that is today fairly impossible to still do. Some maybe a little bit easier challenges. One of the challenges would be incorporating external knowledge. So let's say you have a machine learning model and you ask it this very basic question. You ask it, what time is it? And I give you 10 billion training examples. Will you be able to train the system? Not really, right? It's not machine learning. You have to have the clock to tell what the time is. So one of the solutions, at least, is to incorporate some more knowledge to C. And another solution is maybe that, okay, based on C, maybe you have a system that can retrieve you some more information that then becomes part of the C. And this is actually something where we are also needing to do more and more research in customer service, where you often need to actually know, okay, yeah, what's the name of the customer? Where do they live? Is there some kind of fault in the internet overall at the moment, and so on. And this is something, if you look at standard data sets, typically you don't find this information there. Then we discussed this, of course, a lot. Evaluation of models is difficult. So if I have 1,000 models, I need to have really an automatic way to evaluate them. If I have 1,000 models and each produces me 1,000 responses, I'm not going to have a human who's going to evaluate me 1,000,000 suggestions. So you can use things like Blue Meteor. You can use this Barbie unit test just to check that the model is kind of performing well. And sometimes you can also reuse annotated data if the models are producing similar responses. One more challenge, response diversity. So maybe some of you have actually used Google or Gmail inbox, and now it's also already in Gmail, so it's giving you suggestions how to respond. And sometimes I'm looking at it and it's like, hey, let's do that on Monday. Monday works for me, or I can do Monday. And maybe I actually want to say that, oh, I can do Tuesday. So then it's a bit useless to have Monday 3 times there. So diversity is sometimes something that you actually want to have there. Our customer service system is also such that it gives you customer service suggestions. And if one of them is bad, maybe you actually want to give 2 different ones. And one of the solutions that Google actually implemented is that they always give, or try to give you a positive, if there's a positive response like yes, they also try to give you the other sentiment. So they try to give you a negative one. So they say that, oh no, that doesn't work. Also, maybe you want to have some kind of clusters for your responses, and then you pick from different clusters. So it's going to be different. Sometimes you also may want to just ignore it. You don't care that it's not diverse. Or if you are not doing suggestions, but you're always doing just one response, then it of course doesn't matter too much, as long as it's not always the same response. And sometimes you can also consider doing sampling. So you run your neural network, and you don't always pick the highest probability one. You just kind of use those probabilities to sample from it. The nice part is that you always get something different. The bad part is that you never really know what you're going to get. More challenges. Long conversations and long text in general are kind of notoriously difficult. RNNs were kind of famous for having challenges with this. That's why you started seeing models first like LSTMs, then attention, memory networks, hierarchical, and so on. So if you do want to respond to very long emails, it's a much harder problem in many cases than responding to, let's say, a 3-line customer query or hi, how are you query. Then one of the other challenges is also that maybe you don't always just want to respond with an action with a response. So if the dialogue is, hey, can you forward this email to your manager, and I respond sure, and then nothing happens, I guess you wouldn't be very happy, even though it's a very correct response. So you actually don't necessarily want to have the response just as a kind of dialogue act, but maybe you actually want something else to happen after that as well. And we were analyzing some customer service data again, and sometimes we noticed that, okay, for instance, forwarding emails is something fairly important. You always want to forward some complex emails to some special department. Sometimes these actions are horribly difficult. So let's say if the IT department says that, yeah, hey, sure, I'll come by your desk and I'll check out the computer, incorporate that action into a machine learning system is of course very difficult. It can't walk to the person's desk. So sometimes it's super easy, sometimes practically impossible. And goals are of course something that you may also want to incorporate to your system. And it may be kind of easy. So sometimes you may say that, okay, and sometimes you also may want to consider different goals. So maybe sometimes the goal is just to carry on the conversation or respond in a correct way. So maybe your dialogue can be that, hey, can you please discontinue my subscription? And you're a business and you say that at customer service, and you say, sure. And it's a valid response. Nothing wrong with it as such, except when your manager comes there and says that, hey, we don't want to lose our subscriptions. So maybe the correct response would be actually to say that, hey, what's the problem? Try to resolve it. And then you want to say that, oh, the customer to say that, oh, no need to cancel. Or in the best case, to say that, hey, I want to double my subscription or whatever. So how to incorporate these kind of goals into your system is, of course, also very tricky. You often don't have, for instance, the data for this. Maybe sometimes you can use things like sentiment as a proxy. Maybe the customer is getting happier, and that's maybe a good goal, for instance. And maybe sometimes you also want to use things like reinforcement learning to kind of test different approaches and see what happens. This is definitely something that is not kind of solved yet. And one more challenge. Results reporting of academic papers and blogs and so on is sometimes a little bit misleading. So if you look at academic papers, if you looked at, for instance, this is actually where we started getting very interested in customer service initially, reading one of Google's papers where they feed a system a lot of kind of human-human conversations, and then it starts producing you really beautiful stuff like, hi, hello, could you please let me know what are the operating systems you're using? I'm using Linux. Okay, it was in the SSL VPN of which you stated was broken. So it seems that the machine is able to really produce you good results, but then you replicate the system and you realize that, okay, this was maybe 1 out of 100, but most of the suggestions were not, or the responses were not very good. So if you are reading a paper that claims to have dialogues that are working really, really, really nicely, do remember to have always a bit of a skeptical eye. I think that concludes pretty much my talk. So just to recap, things like sequence-to-sequence are quite good to beginning to build a deep learning model, and then you can go with more funny architectures. You do want to definitely do human evaluations, but once you realize that you need to evaluate more than a couple of 100 sentences, you probably want to consider also some automatic metrics. And dialogue evaluation is definitely not a kind of easily solvable problem. So do start somewhere fairly narrow and do kind of find really good data for it. Make sure the problem is really kind of solvable before you start building a system, and then realize that you have many of these challenges that I have stated, because they are really, some of them are many years of research before they are solved. I think that concludes my talk, but I would love to get any questions or opinions or kind of challenging comments if you guys have any. Yep.
Thanks for your talk. My question, if you can you say what you use in production really? Generative models or retrieval models? Or maybe you can give some more details about some exact architectures, if it's possible.
Yeah, very good question. Let me think what I can tell you. I probably can't tell you all the details of our architecture. We are using many similar models that what you've seen here. And what is also fairly well known is that doing completely generative models, I don't think anyone can do that very reliably. Also, kind of doing just basic sequence-to-sequence will not get you very far. Which exact architecture we are doing, sorry, I can't really, really tell you that.
Not another question, but I read article, but now I can't find it. It's a recent article, and Joshua Benjo is one of the authors of this, about evaluation. And in new metrics, the architecture use several LSTMs inside. And what do you think about this? Maybe you read this article or not? I'm sorry, I don't remember the name of this article, but it was recently published.
Okay, that's a bit difficult to comment without all the details. Obviously, LSTMs and so on are fairly commonly used. Benjio's group was publishing recently one of these papers where they compare evaluation metrics, and they do propose one kind of neural net-based evaluation metric as well, and then they compare blues and so on. I think they are all fairly valid. I think one of the challenges that I think many evaluators try to do is that you try to build a model that evaluates your responses and gives you kind of a perfect human score. I think the challenge with that approach in general is that if you can build that model, then you can just feed it every possible response, and it's actually a model that can act then as your main model. So kind of building an evaluation model is, in a sense, it's not a very it's not almost a possible thing to build a better evaluation model than the model that you're building, because if you do have that, then you can basically use that just as your main model.
So do you mean that building a good discriminator is as hard as doing a good generator?
So what I mean is that because you have things like retrieval-based models, if you do have something that can discriminate, you can just discriminate through your whole data set, and then you can optimize that so that you don't need to discriminate between all of that. So assuming it's in your data set, it does, then you have already the perfect model. And then, of course, you can have a generative model, and that just kind of augments your response space. So yeah, I think kind of building a really good discriminator is quite difficult.
Pyry, thanks again for the lecture on dialogue systems in production. And from my experience, I remember that the real curse of more or less useful dialogue systems is that there is very little data. So, well, you've mentioned crowdsourcing, and you say you're a deep learning startup. So the question is, if it's not a secret, what do you do? What do you do with that? Either you do like massive crowdsourcing for the annotation, or did you find some special tricks for dealing with some semi-marked top data or unmarked top data?
Yeah, so very good question. So I think there are actually two different places where you need a lot of data and a little bit less data. So when you are training your model, you do need a lot of data. When you are evaluating your model, you often are okay with, let's say, doing 100 or a couple hundred annotations, and that gives you at least a good idea whether your model is on average good. So we do need a lot of data for training the models, and that's why we are operating customer service, where many companies are logging all of their historical conversations. So many, let's say, telcos, for instance, have millions of customer interactions in their data set already, and we use that to train. But then when we start evaluating our model, then we only give, let's say, a few hundred to an evaluator to see is this a good model, and that's when it's not too expensive. But you do need those few hundred thousands or millions in the training set.
Sorry, one more. So did you find a way to deal with raw logs provided by your clients?
Yes, so what we are getting is that we are getting conversation logs from a client. So a client shows us conversations where there's a customer service operator and then there's a human. And because large companies have millions of customers, it means that we get a data set which is in the millions of conversations. And then we contract to more companies and get more and more of those. And that's where we are training our systems. The sad part is that if you are an individual researching dialogues, you typically don't have access to those data sets. And it is fairly difficult to actually build systems. There are a couple of data sets like the movies and Twitters and so on, but some of the best data sets are unfortunately locked in the company's vaults.
Thank you.
An extension from the previous question from that guy. In paper towards an automatic Turing test, the authors propose to create a network that learns to mimic human evaluators' scores.
Yep.
What do you think about that approach?
I don't think it's. I think it's kind of works. I think the challenge is again that if that model works better than your main model, essentially you should just use that model. So you do just use a new data set to train a better model essentially, and then you just use that. So you're using one model to teach another model, and it has been trained on kind of better data. Of course, if like you can use it to some extent. I think it's at least a good complement to Blue, but I don't think it's kind of perfect in that sense.
But maybe it mixes two approaches like generator and discriminant and
generative, or
ranking approach.
I don't know if it does ranking, but I think the good part. The good part is, I think generally it's good to actually look at different metrics. So if you have a model that has a good log loss, it has a good perplexity, it has a good Blue, and it's good on that, it's probably a better model than one that is. So I think, and it gives you also much more balanced view. So maybe the Blue score would be a little bit, like if you just look at one metric, maybe you're missing something. So I don't think it's a bad approach as such, but I think it's a little bit twisting it also, because then you just have to get a lot of annotation data, and then if you are outside of those, let's say 5,000 annotations that you did, then you are then that model is like operating in the dark. Because your main model has seen, let's say, 1 million conversations, that model has maybe seen a few thousand conversations, and maybe the ones that you are now trying to evaluate are outside of that, that data set.
Sounds reasonable. Thank you.
Okay, thanks for your talk. And about achieving the goal, for example, the competitions of evaluation criteria of this competition is quality and breadth and the engagement of chatbots. So we can think of reinforcement learning to maximizing this score for our chatbot.
Yep.
But one potential problem might be the this score is given per dialogue. So it is very sparse supervision signals.
Yep.
So I guess with reinforcement learning with this signal may converge very slowly. So do you think any promising solutions for this?
Yeah, so my approach would be a little bit similar as how they train things like Go as well. So you kind of don't just try starting with the reinforcement learning signals or kind of signals that are super weak. You start with something a little bit simpler and kind of I don't know if you know what auxiliary targets are. So it's a target that you have kind of on the way. So you have some kind of target that is easier, and you train first, for instance, more on that, and then you start using. Once your model knows at least a little bit how to act, then you can change the target to something that is much more distant. So then you're kind of, for instance, your model learns what kind of responses in general it could respond, and then how to pick the correct one. Maybe then you could use reinforcement learning to do that. That might be a valid way, because if you try starting with something where the training signal is extremely weak, your model will not get anywhere very quickly. Maybe you'll train for a month and then it will, but that's a bit ballpark then.
Coming back to previous questions about the metrics. So automatic metrics are not perfect. Humans disagree. And have you had situations when a model performs well in the metric space and your human evaluators, but you come to a client and the client says, no, that's not what it should do?
Yeah, so typically you see your loss going to fairly low levels and your blue levels going to fairly high levels, definitely. And then you can start checking at the actually human evaluations. And I think what you typically do see is that if you reach a certain blue score, then everyone will be fairly happy. But then you don't exactly know that before you have done a couple of human calibrations. So yeah, if you reach, let's say, blue score of 34, it doesn't, and it's a new data set, you have to first check, does that mean something with humans? And also of course, there's the chance that it's likely that it doesn't completely correlate with humans. But then if you do get something that has a higher automatic metric, typically it does correlate.
To ask is when it performs well in the automatic metrics, and your own human evaluators also approve it. But your client still disagrees. Have you had that?
Yeah, definitely. So that can happen, and where that happens easily is if your clients are very expert in the domain. So if our model is suggesting something that, yes, sure, you can do that, but for instance, we are working with one company that has a lot of legal questions, and to my common sense and my colleagues' common sense, it made sense that the answer is yes, but then the client's legal expert says that, oh, actually, because of this and this and this and this, the answer is actually no. It's not very, very common. Usually you can understand what the client is probably going to say. But if it's some very specific domain, then that's typically when there might be still disagreement.
So do you address it on a client-by-client basis, like you build a specific model, or you try to improve your model so it's more general and can handle everyone?
Yeah, so we do train our models always client-specifically, because the questions are typically different. We work in many industries, so we are working with government and for instance, telco and so on. So if you train the same model on government and telco, the questions are, of course, different. And what you want to do when you have a new model and you are confident yourself that it's good is that you roll it out to a few people who are kind of more like the test users, and then you may still calibrate it a little bit based on the feedback from them, so you don't do a full rollout initially.
Okay, thank you everybody for questions, and let's thank Pyry again for his great lecture.
Thank you.
And now, actually, we have 1 minute till Jason's lecture, but we have not connected with him yet. So I think that maybe we have 5 minutes for break.